All right, everybody, we're moving on to our next topic here. Building off of normal distributions, we're going to be getting into something called standardization. Okay, so our objective today is to talk about standardization, specifically something called z-scores and how to use them. That's what we're going to be primarily focusing on in this section. So let's dive into it. Okay, standardization and z-scores. Now, what we learned in normal distributions is that we can find the percentages of data. You know, if we're working with the mean and exact standard deviations. So this is the graph we used in normal distribution section. So I know that, for instance, 34.13% of data falls between 100 and 115. I just know that immediately because of those percentages that have been calculated based on a normal distribution. But what if I want to know how much of the data falls between the mean and a very specific score, right? A score that doesn't fall exactly on one of the standard deviation markers. So for instance, what if I wanted to know how much of the data, what percentage of data falls below 108, like an IQ of 108? I can't use the percentages we used last time because those were calculated based on the exact standard deviations. So how do I do this, right? Same can be said about the probability. How do I find the probability that someone will score higher than 108? I still can't do that using the percentages we learned last time. So this is where standard deviation comes in and is very helpful. Okay? We need to do something called standardize the data set in order to address those more specific scores. So what does standardizing do to the data set? It transforms the data set's mean and its standard deviation so that way it goes from whatever it equaled normally to now equaling 0 for the mean and exactly 1 for the standard deviation. So we're taking the data set from its normal numbers that it had originally, and we are quote unquote converting it to a new format, one in which the mean of the data set is 0 and the standard deviation equals 1. Now, the result of this, when we do this to the entire data set, every piece of data goes from being what's called a raw score or original score to being a z-score. It's also called a standard score, but I'm just going to refer to it as z-score because it's quicker. So any score in the data set that has been standardized is called a z-score. And this here is the equation to calculate that. So you take a value of x, which would be one piece of your data. You subtract the mean from it, its original mean, and then you divide that difference by the original standard deviation, and that's how you get a z-score. Let me show you some examples of how this works so this can sink in a little bit more. So let me show you how the mean actually becomes 0 and the standard deviation becomes 1. So let's say that I take the mean and I plug it in for x. Okay, so x minus the mean. So 100 minus the mean, 100 minus 100 is 0, and 0 divided by the standard deviation of 15 is 0, because 0 divided by anything is 0. So that's how we make the mean equal 0. Standard deviation is 115. Minus the mean, 100, you get 15. 15 divided by 15 is 1. So that's how we go from having a standard deviation of 15 to now having a standard deviation of 1. And now we can do this with every other score, and then we can then convert it to a z-score. So let's take that score 108 that we were using before. So let's take 108 minus the mean divided by the standard deviation of 15. Okay? So you get 108 minus 100, which is 8, divided by 15, and you get a z-score of 0.53. Okay? So it's going to land in the same place as the original score. The placement of the score, the z-score, doesn't change. We've just converted the number to a new number, but it still falls in the same area. In fact, if you look at this curve here and you look at these numbers 0, 1, 2, 3, -1, -2, -3, I was really showing you the standard scores or the distribution, the standardized distribution, though you didn't know it yet. So 100 became 0, right? 115 became 1, and 0.53 falls between 0 and 1. So everything stays in the same place. We've just converted the numbers to z-scores So that way we can begin to address the issue of finding percentages for specific scores. So z-scores is a stepping stone. So that's the first step. So what do we use the z-scores for? Okay. Once we have a z-score, we can use it to find these percentages and probabilities. And we need to use something called a z-score table. Okay. Now on Blackboard, you're going to see a PDF file called Critical Scores Table. Get that file and have it downloaded on your computer. Print it out would actually be easier. And have that with you when you're doing every assignment and when you're going through most of these lectures. And I'll always emphasize when I'm going to bring it up. We're going to be referencing the tables in that PDF a lot. The first table we're going to work with is called the z-score table. And I'm going to show you how this works. So if you don't have the table yet, go ahead and pause the video and go get that PDF opened or print it out if you can, and have it in front of you so you can follow along with me as we're going here. So the table is going to look like this. You're going to see columns. One's going to be the z-score column. Okay, and the other one, the one next to it is going to tell you the area between the mean and the z-score. It's going to tell you the percentage of data between the mean and whatever z-score it's connected with. So the table only lists positive z-scores. Now, the reason for this is because on a normal distribution, the negative side is symmetrical with the right side. So a z-score of 0.50 is the same as a z-score of, because 0.50 would be right in the middle. A z-score of 0.53 is the same, no, 0.50 is not right in the middle, sorry, excuse me. A z-score of a positive 0.50 is symmetrical with a z-score of negative 0.50. Like the distance from the mean of 0.50 is the same as the distance from the mean to negative 0.50. So they're going to have the same percentage of data between the mean and the z-score. So you can calculate negative z-scores, and you're going to come across several of them in these examples and on your assignments. But the percentage of data between the mean and the z-score is the same. Okay, positive or negative. So don't get confused by that. You're going to be looking for the positive z-score, but remember, you still have a negative z-score if that's what you calculated. Whatever you calculated is what you're working with. Okay, and this is the details that I just listed out here. Now, you're going to find the z-score you're working with, and you're going to grab that percentage, and you're going to write that down. And that's going to be used to answer our question here. So I'm beginning to tie this together, so stay with me now. Now, what percentage of scores are between 100 and 108? Well, we know that we have a z-score of 0.53. So look up a z-score of 0.53 in the z-score table and find the percentage of data between the mean and that z-score. Now, what you should look up and find is a z-score of 0.53 and its associated percentage of 20.19. So 20.19% of the data is between the mean and a z-score of 0.53. Or in other words, 20.19% of people have an IQ between 100 and 108. There you go. So that's how we're able to find the percentages for specific scores that don't land exactly on one of the standard deviation markers. Now, that's if we get a question that asks us just for percentage of data between the mean and the z-score. What if we get a question like the one that I gave earlier? So let me put those back up here. Like, for example, how many people score below a 93? How many people have an IQ below 93? Okay. What you're going to have to do is find the z-score. Okay. So how many people have a score below 93? So you're going to take 93 minus 100 divided by 15, and you should get negative 0.46. It's a negative z-score. It's on the left side. So 93 is on the left side. It's below 100, between 85 and 100. So negative 0.46 is between 0 and negative 1. Go to your z-table and find the percentage associated with that z-score. Now remember, you're going to just be looking for the positive version of it because the table only lists positive z-scores. But keep the z-score as negative because it's on the negative side. So if you go to the z-table and look up 0.46, you should find a percentage of 17.72%. That is how much data is between a z-score of negative 0.46 and the mean. Okay. Now, what the question is asking is what percentage of data is below a z-score of negative 0.46 or IQ of 93. So it wants you to find out this data here, right? What's below the line, not between the mean and the z-score, but the data that's below the z-score. So what you would do is you need to find, you have the percentage 17.72. You know that the entire left side of the curve is 50%. So take 50% minus the percentage that you found from the table. And then whatever is left is the percentage of data below a z-score of negative 0.46. And what you would calculate is 32.28%. So tying this all back to the initial question, how many people score below 93? 32.28% of people score below an IQ of 93. And that's how a z-score can help us calculate our percentages and our probabilities using specific scores, okay? So remember, all you do is you take the same percentage and you convert it to a decimal. What is the probability someone will have an IQ below 93? 0.3228, right? And that's how that works there. Now I'm going to give you some next questions here, and I'm going to just put them on the screen, pause the video so you can work through it, and then I'll show the answer and kind of walk through it, okay? So here's the question. How many people, what percentage of people have an IQ between 112 and 125? Pause the video, try to work that out, and then I'll walk us through it, see where you went, see what you got right. So here's the first thing you need to do. You need to, well, let me tell you, the final answer you should have gotten is 16.34. You got that? Great, you did the right process. If you didn't get that right, let me walk through what it is, how to do it, and see where you went wrong. So what we need to do is start with converting our scores to z-scores. So let's start with 112. 112 falls on the curve between 100 and 115. Take 112 minus 100 divided by 15, you get a z-score of 0.80. Great, first z-score. Find the percentage from the table, from mean to z, is 28.81%, okay? Now, 125 falls further from 112. It falls between 115 and 130. We convert that to a z of 1.66, okay? And the mean to z is 45.15, right? So now we have our percentage of 45.15, and we have 28.81. Well, what you want to know is how much of the data is between 112 and 125. So since these two sections of the curve overlap, what you would want to do is subtract them from each other. Subtract 28.81 from 45.15 to get the difference, to get how much is between them. And that's where we get 16.34%. Now, if you didn't do this, what I recommend doing is drawing out on a scratch sheet of paper this normal curve like you've done here, like I've done for you on the screen, and make the markings I've done like on the screen. Do what I've done on the screen here. When you can visualize this, that is really good, is what's going to help it click for you. So mark out your scores, draw out the normal curve, and this will be very, very helpful. Okay, let's do another one. What is the chance, probability, someone will have an IQ above 77? Pause the video, give it a shot, and then I'll walk us through it. All right, so what you should have gotten is 0.9370. And here's what you should have done. Convert 77 to a z-score. 77 is between -2 and -1. So the z-score is going to be negative. And that's exactly what we find. We get a z-score of -1.53. Now you have to find the percentage of mean to z. From the table, that's 43.70%. So we know that 43.70% of the data is between -1.53 and the mean. Now, we want to know how many people are above 77. So that includes from 77 to the mean, and then all the data above the mean. And you should already know that all of the data above the mean is 50%, just like all the data below the mean is 50%. So I've already got 50% I'm working with, the right half of the curve. So if I've got 50% on the right half of the curve, and I have the percentage from 77 to the mean, then you would just add those two together, okay? And when you add those two together, you get a percentage of 93.70. But remember, the question asked for chance, so you got to convert it to a probability at the end. So you get 93.70, and then you convert it to 0.9370.